In the Airbus A320, the fly-by-wire system operates under what is known as normal law. In this mode, the flight control computers interpret side-stick inputs and convert them into optimized aerodynamic commands. This means that multiple protections are active simultaneously, including low factor limits, pitch attitude limits, and angle of attack protection. A stall occurs when the angle of attack exceeds a critical value, causing a rapid loss of lift. This can happen during low-speed operations such as go-rounds or during excessive maneuvering. To prevent this, the A320 includes high angle of attack protection, which acts as the final barrier before a stall. High angle of attack protection ensures that the aircraft remains within a safe aerodynamic envelope. It prevents the aircraft from entering a stall condition by limiting excessive nose-up commands. The A320 defines 4 key angle of attack thresholds that form the protective envelope. The alpha VLS represents the minimum selectable speed and defines the lower safe boundary for normal operations. Alpha protection, or alpha prot, marks the point where the protection becomes active and the flight control changes. Alpha floor triggers automatic toga thrust through the autothrow system, providing additional energy to prevent further speed decay. Finally, alpha max represents the maximum allowable angle of attack. Even with the full aft side stick, the limit cannot be exceeded. Together, these thresholds define the safe operating envelope of the aircraft. As the angle of attack increases, lift also increases until it reaches a maximum value, which defines the stall condition. High angle of attack protection prevents the aircraft from reaching this limit. In normal law, when the angle of attack exceeds alpha prot, the protection activates, and without pilot input, the aircraft stabilizes at this value. With the aft stick input, the pilot can increase the angle of attack further, up to alpha max. This maximum value cannot be exceeded, even with the full aft stick. On the primary flight display, V alpha prot indicates the speed corresponding to alpha prot and appears at the top of the amber band. V alpha max represents the speed at alpha max and is shown at the top of the red band. Another important reference is the VLS, the lowest selectable speed, which is not directly linked to the angle of attack. When angle of attack protection is active, several indications are presented to the pilot. On the primary flight display, the speed tape shows amber and red bands corresponding to the protection limits. The ECAM may display an alpha floor message, and oral warning may also be triggered depending on the situation. In response, the pilot should verify that the thrust is increasing, reduce the pitch attitude, and maintain wing level. These conditions help the aircraft recover to a safe flight condition. In this sequence, the aircraft is in level flight while thrust is intentionally reduced to idle, disconnecting the autothrust. The autopilot maintains attitude, causing the speed to decrease. On the A320, high angle of attack protection activates when the autopilot disconnects at approximately alpha prot plus 1 degree. The aircraft then pitches down to reduce the angle of attack towards alpha prot. If aft side stick is applied, the angle of attack is maintained above this value. At the same time, the alpha floor function may activate, automatically commanding toga thrust to restore energy. In normal law, the Airbus A320 provides full flight envelope protection. Even with full side-stick input, the aircraft will not exceed its aerodynamic limits. When the angle of attack is active, the aircraft automatically limits the angle of attack to alpha max and applies pitch corrections as needed. This results in smooth and predictable handling, ensuring that a stall is physically prevented. Understanding this behavior allows pilots to trust the system during critical situations. Proper training is essential to fully understanding and effectively using angle of attack protection. Pilots should practice scenarios such as wind shear recovery, stall warning demonstrations, and alpha floor activations in simulators. It is important to recognize when protection is active and respond correctly. Pilots should trust the flight envelope protections while maintaining situational awareness and control of the aircraft. Mastering these concepts ensures safe and confident aircraft operations. My name has been Mario Blazevski, and throughout this video I've guided you on how to use the high angle of attack protection on the Airbus A320. Thank you.